Section 8.4 Comparison Test. Often a given series will have the same general appearance as another series whose convergence properties are known. In such case, it is convenient to use the properties of the known series to determine those of the given series. The goal of this section is to examine three comparison tests for making these determinations. The first of the comparison tests is called the direct comparison test or baby comparison test. Suppose 0 is less than or equal to AK, less than or equal to BK for all K. It means that when you plot, the terms AK lies below the terms BK. We can make the following conclusions. If sigma BK converge, then sigma AK converge. If sigma AK diverge, then sigma BK diverge. What does this test say? Let sigma AK and sigma BK be series with non-negative terms. The series sigma AK converge if it is smaller than a non-convergent series. The series sigma BK diverge if it is larger than a non-divergent series sigma AK. That is, smaller than convergent is convergent, and bigger than divergent is divergent. Please notice that to use any of the comparison tests, the terms must be positive, otherwise you may make wrong conclusion. For example, minus 1 divided by k is less than 1 divided by k squared for all k. When you plot, the term of 1 divided by k squared are positive and lies above the x-axis. The terms of minus 1 divided by k are negative and lie below the x-axis. We know that sigma 1 divided by k squared converge because it is a p-series with p equals 2, and sigma minus 1 divided by k diverge because it is the opposite of the harmonic series. So, smaller than a convergent series may not be convergent if the series are not non-negative. Test the series sigma log nk divided by k for convergence. We have log nk divided by k is greater than 1 divided by k for k greater than or equal to 3. And sigma 1 divided by k diverge because it is the harmonic series. So the direct comparison test tells us the given series must diverge. Test the series sigma 3 divided by 4 to the power of k plus 5 for convergence. We have 3 divided by 4 to the power of k plus 5 is less than 3 multiplied by 1/4 to the power of k for all k greater than or equal to 1. So the given series dominates the convergent geometric series sigma 3 multiplied by 1/4 to the power of k. This geometric series converge because 1/4 is less than 1. So the direct comparison test tells us the given series must converge. Test the series sigma 1 divided by 4 multiplied by square root of k minus 3 for convergence. We have 1 divided by 4 square root of k minus 3 is greater than 1 divided by 4 square root of k for all k greater than or equal to 2. So the given series dominates the divergent p-series sigma 1 divided by 4 square root of k. This series is convergent because p equals 1/2, which is less than 1. So the direct comparison test tells us the given series must diverge. It is not always easy to make a suitable direct comparison between two similar series. For example, we would expect the series sigma 1 divided by 4 square root of k plus 3 to diverge because it is so much like the divergent series sigma 1 divided by 4 square root of k. We have 1 divided by 4 square root of k plus 3 is less than 1 divided by 4 square root of k for all k greater than or equal to 1. So, sigma 1 divided by 4 square root of k plus 3 is dominated by the divergent series sigma 1 divided by 4 square root of k, which means the comparison test cannot be used to determine the convergence of the given series. In such situation, the following test is often useful. Limit comparison test. Suppose AK and BK are positive for all sufficiently large k, and that lim when k tends to infinity of AK divided by BK equals L, where L is not 0 or infinity. Then sigma AK and sigma BK both converge or both diverge. What does this test say? We have the following procedure for testing the convergence of sigma AK. Step 1. Find the series sigma BK whose convergence properties are known and whose general term BK is essentially the same as AK. Step 2. Verify that lim of AK divided by BK when k tends to infinity exists and is not 0. Step 3. Determine whether sigma BK converge or diverge. Then the limit comparison test tells us that sigma AK does the same. Test the series sigma 1 divided by square root of k plus 3 for convergence. The general term of the given series seems to be similar to the terms of the series sigma 1 divided by square root of k. We compute the limit lim AK divided by BK. It equals to lim of 1 divided by square root of k plus 3 divided by 1 divided by square root of k equals lim of square root of k divided by square root of k plus 3 equals 1. This limit is finite and positive, so the limit comparison test tells us that a given series will have the same convergence properties as sigma 1 divided by square root of k. Sigma 1 divided by square root of k is a p-series with p equals 1/2, so it diverges. The limit comparison test tells us that a given series must diverge.